Okay, and then share screen. Share screen here. Okay. So today we will start with a new topic. Okay, it's about generic. I will start annotation, and I will see. Yeah, so I will try this. So you guys can see. Can you guys see? Like I wrote generics here. So just let me just take a try. Okay. Stop sharing. So I'm just checking. Can you all see what I just wrote?
I could see the code and what you wrote.
Oh, okay. So you can see that. Okay, so good. Because I use pens, I'm not sure if you guys can see it. Okay, let's. So today we will start with a new topic. It's about generic. Oh, I needed to enable annotation. Okay, it's about generics. And previously, when we discussed stack and the queue, we kind of use it already. You remember, like for the queue, is it? And I mentioned this queue, it's from collection libraries queue. And each time when we try to use it, we needed to have this angle brackets and plug in with some concrete type. Concrete type, is it? And the concrete type, not include, so not allowed, so not a primitive, not a primitive type. So must be some concrete class type, is it? So, but it's very handy as the handy thing with the collections stack and the queue is within the library, they just basically define one-time queue. Is it? And basically later on we are going to see they don't have multiple files for the queue definition. They just have a single queue Java file defined for the queue class. And that queue class basically later on we are also going, it's called the generic queue. Okay, and with one definition, but you can apply it to whatever type you want, is it? So that's pretty handy, is it? Pretty convenient, and also save a lot of our work to write for each type of queue or stack, like our own one, is it? So our own one. So far we learned is you need to define the type either like integer or string or like char, is it? Of those. So each time then we needed to have a file, a corresponding the collection file or the a corresponding queue file or corresponding Java file defined for it, is it? So it's not in like in one app. If you wanted to have both integer queue and character queue, then you needed to include two of your queue, your own queue in that case, two Java queue file. Is it? So that's not in case if you have 100 different type of queue, then you need to have 100 queue Java file. So that's not efficient, is it? So in order to avoid that, we have a new concept, we call it generic. So the idea is, can we define a very general one? Is it? So just kind of like the concept, like a Word template. Like the template, is it? Or like a PowerPoint template. Is it? So you can open a template, is it? And then you can fill out some customized of your contents, is it? So the concept, a little bit of like that kind of concept. So we also kind of provide a template, then we can customize when we want to use it with a specific type. Okay, so that's the general idea kind of seen from what we previously discussed. And let's first take a look. So how do we design a generic class? So for generic, what we are going to discuss, oh, I need annotation. So what we need to discuss here, so generics. So we are going to discuss two things regarding generics. One is generic class. The second is generic method. Okay, so we are going to start with a generic class. So let's first take a look at this, a very simple generic class. So I just defined it. So this part is still the same. The public and your keyword class and the name. So the class name, we call it generic, but be careful, it's about after class, we have the angle bracket and a T, is it? And what is this T? So this is a generic type. Previously, whenever we define class, we never have this angle brackets, is it? And plug in something. No, we never, is it? But this time, you see, after you define give the class name, then you need to have this angle brackets T. Okay, so that's represent a generic type. And then within the class, then let's see. So for the data member, for the instance variable, so this is our instance variable. And for this instance variable, then the type is T. And of course, if you want, you can still have some other instance variable, like suppose private, integer, number. You can still have regular one. Okay, this is still allowed. Okay, but generally speaking, whenever you define a generic class, you should at least have one instance variable, and the type is matching the generic type that you given. And you can, the T, it's not mandatory that you need to have T. You can have T, you can have any other name for it, for the generic. You can, generally we use, like you can also use E, you can also use like U, and you can also define like element type, is it? So you can pick different kind of character or string for that generic type, okay? And then within this function, we also have the get function, so accessor we already learned, but this time, the return type, you see it's a generic, is it? So it's consistent with your class generic type. And then we also have the set function, is it? And this set function, same thing, did you see the parameter type? You also change, we change it to the generic type T, is it? So if we take another look, we are going to see, like for this class, not a huge difference from what we already learned. It's just, okay, you need to have this angle brackets and specify the generic type, is it? And then within it, instance variable, you can still, so for the instance variable, it's still allowed the regular one, but you can still you can also give a generic type of instance variable. And the same thing for your other methods, okay? Like in this case, the get function, its return type can be the generic type. And the set function, the parameter type can also be generic type. And of course, you can also have other functions, is it? Like suppose public int get number. So that's still allowed. So your get function, set function. So all of your other instance methods, if you don't want to use anything related with generic, that's also fine. That's still allowed, okay? So this is how do we define a generic class. And then next, let's see. So in this project, I have 3 files in this one. Okay, I have one called generic type Java. That's for our generic class. And I have another, we call it utility.java. It's very simple. And then we have the driver, okay? So the second one, let's take a look. for this one, I needed to, for this one, for this class itself is not a generic class. So it's just a regular class. Is it? And within this class, I just have a single method called compare. Okay, and this method is a static method, so it's a class method. It doesn't need any instance to go ahead to use it, is it? But if you take a close look for this method definition, okay, you have the accessibility, static or non-static, return type, Boolean function name, is it? But pay attention to this. So before the return type, we also have a angle bracket and T, is it? So that also represents the generic. Okay, so this method, then take a further look. For this method, and it has two parameters, is it? And the first parameter to use what? Use what we just defined, the generic class, is it? So it also has the generic, is it? Generic plugged in. So for this method, then this method is called a generic method. So it doesn't have any specific type, is it? It's all regarding generic, is it? And what it does is it's quite simple, is it? Just try to get, so this part is to call our generic type class get function, is it? And then to compare it with the other objects. Okay, so pretty straightforward, this method. So the only difference here is whenever you try to write a generic method is, this is mandatory, okay? So this part is mandatory. So you do need to have that angle bracket T, okay? Angle bracket, then this represents, this is a generic method, okay? And then your parameter, you can also have some generic type for your parameter. And in this case, is we use a generic class. So you basically over here, you have both of the generic method, and you also apply the generic generic class. And then let's see, how do we go ahead to use it? Is it? So then in our main here, let's see, we first create what? The generic type of instance G1, is it? And the G1, then in this case, the type you plug in with what? So this is a concrete type. So over here in main, you need to plug in, okay? So make sure, remember this. So in main, so no generic. In main, you must have concrete type. Okay, so over here we have a G1 instance, and the type is what? Is a string type of generic. And then you go ahead to call new, call its constructor, its constructor to create. And when we do this over here, if you take another close look, is it? And we didn't repeat the T, so you can leave it empty. That's allowed. So this is allowed. Okay, and so you can leave it empty, and the program will know that over here, basically, it's string. Okay, so it will know it. Okay, so this is called inference. Okay, so it know from your the left part declaration, it's a string. So it know, okay, when it calls the constructor, it's going to plug in with a string. Okay, and here, there is another concept here I want to mention is Java. Java is a strongly typed programming language. Okay, Java is a strongly typed programming language. And what we mean here is whenever you have a variable, basically G1 is a variable, is it? You need to give it a type, is it? So that's why over here, okay, I said, okay, I want to have the type is generic type class, is it? But generic type class is concrete data type is what is a string. So it's a string of generic type. So in this case, your G1 will be a strongly typed. So it follows the rules, is it? And previously, we also learned another concept, if you recall, object, is it? And you may say, oh, object, it's very broad, is it? It's also very general. Why do we still need a generic? Why don't we just create some class with object, then whenever you want to use it, then you can cast, is it? So previously, I remember when we discussed stack and queue, and whenever we call the clone method, the clone method, it's always return what? It's always return object, is it? But for your specific type, then you need to cast it, is it? So over here, when we have generic type, then no casting needed. No casting needed. So it saves a lot of work, is it? And also, when the program gets compiled, it knows, okay, this type is a string of that generic class. So it won't cause any like assignment or any type related error. So in this case, then it can avoid the error caused by type. Is it? And because with casting, sometimes if you forgot to do casting, it may still cause a problem. And also the other issue with casting and versus the generic type is generic type, you have specific type stated here. When you do new, is it? Then in heap memory, it knows exactly how much memory it's going to allocate. So it's also very precise. So that's all of the nice things for generic. So over here, we know, okay, first, we create this G1, is it? We use the generic class. And the generic class, but when we plug it in, we plug it in with a string. And the same thing for G2, is it? It's also a generic type, but it's a string, is it? And then you can just do plug in whatever, is it? And you remember previously the set function parameter is T, is it? But over here you already specify, okay, all related with G1 is going to be string, it's going to be string. So that's why over here it automatically load, it will replace that T with a string. And then next, let's take a look at the I1 object. For the I1 object, then this time what we plugged in with the concrete type is an integer, is it? So you can see that in this one main, we just wrote one. So we just wrote one generic type class, is it? But we create, but over here we create two different type of instance. Is it? The different type instance, one is string, is it? The other is integer. Yeah, so it's quite convenient, is it? And in this case, we can also see this is really achieved what? Achieved code reuse. Is it? You just define a single file, but you can very convenient to plug in whatever concrete type you want. Okay, so we have that instance I1, is it? And same thing for the instance I2. The type is also integer of the generic type, is it? And when we plug in over here, that 100, 200, and the type should be integer, is it? So integer is a class, but the set over here, the set is 200. This is primitive. So here the question is, how can this be allowed? Is it? And let's see. Let's just. Oh, I forgot to clear. It's clear. And let me just stop a little bit. And so here, the question, I will say the question is regarding that. So why can we call set with some primitive, while set is, should be integer, is it? Should be an integer parameter. So why can we do this? So anyone knows the reason why can we like plug in with a primitive type? Because the set function itself, the type should be integer, is it? Yeah, very good. Okay. Yeah, so the reason is because of auto boxing. Okay, so remember that. Okay, so we just shared the answer is because of the auto boxing here. So the concept is called auto boxing. Okay, so that's why you can plug in directly with primitive, okay? And then next, let's see over here. Let's first move to the remaining part of the program. Okay, let's see. The compare function, is it a compare method? Compare method, we define the compare method as a generic method, is it? And this method is a generic, so you because we have that angle brackets T there, is it? And the two parameters are two generic type of class. And then let's go back here. So here we try to call that compare method. That we call the compare method. And this time we plug in with what? With G1 and G2, is it? So here we call generic method. Call generic method. And call that compare generic method. And why do I need this utility dot? So the question here is, why do we need a utility dot? It's because, remember, we said this method is what? It's a class method. Or we call it a static method. Is it? Because it's a class method, static method, so no instance needed. And you just invoke it with the class name, is it? And over here, then you may also see, oh, looks weird whenever we try to call the compare method, is it? So after the dot, it's not just a function name. You also have this angle brackets string, is it? So that's one option, okay? Whenever you want to invoke a generic method is you have the class name, then dot, and then the angle brackets and plug in with concrete type, okay? Then you go ahead, just call the method as what we learned before to call any method. But let's take a look with I1 and I2 case. With I1 and I2, when we plug in, you see this time You just call the class name dot and then the class method is a static method. We didn't plug in with the angle brackets and the concrete type string, is it? So this is also fine. So this is also allowed. So you have two options. So this is option one. Whenever you want to call a generic method, so you specify the type for the concrete. Otherwise, this is another option. So option two is you don't need to specify, is it, the type. And in this case, the compiler will infer it based on whatever you plugged in. Then it know, okay, what is the concrete type it's going to be. So in this case, basically is it skip the integer part, is it? You just skip it. So that's also allowed. Okay, so that's this generic method that we call. And then next, let's take a look of the other method, generic method that we defined within our driver program. So this time we define this equal. We define this is equal method. This method, if you take a look, you will find, okay, this is a generic method because we have that t, angle bracket t defined. Is it before the return time? Make sure it should be before the return time. Is it then the parameter are the same? It's some generic type. Is it under the calling? So this function is very similar as our compare method. Is it? But this time we implement it within this application class. And then next, let's see how we call it. Is it to call this is equal? So here we also demonstrate there are two options you can do. Is it? And the first one we call this generic method, and you plug in, and you also specify the type for the concrete type for this generic method. So I said, oh, I'm going to convert it to a generic to a concrete type of string. And over here, you also mentioned the class name, is it? So this is fine. This is allowed. And then for the second case option, over here, you just call this is equal method, is it? We didn't specify the class name. We also didn't specify the concrete type, is it? And this is because this is within the same class, is it? So you don't need to specify the class name. You just go ahead, call this. But this time, what's the type initiated? This type initiated is with integer, is it? So this generic method, after you invoke it, it takes care of integer, is it? For this is equal. When you invoke it, it's take care of string type, is it? But we just wrote this single method with a very general definition. It doesn't care about the type. It's just a type T, is it? But then later on, you can customize to plug in that T with whatever concrete type you want, either integer or string. But always remember, no primitive. This is a key point, okay? With generic, no primitive, okay? So that's a key point. You always need to pick a specific type. Okay, so this example, we can kind of like run it to take a look at the result. Yeah, so did you see it can do the compare? Is it apply to any type? So this is quite a convenient way that for generic, we already see both ways for generic class and for generic method. And what next we are going to see is, let me find the second example. The second example, let's take a look here. I'm going to share the screen. Okay, and this time if we take a look our class, so this time I define a new class. This new class, I define it as, I call it a measurement generic. Okay, and if you take a look, oh, it's a little bit more complicated compared with our generic, the first generic class example. This time we still have angle brackets, is it? But with angle brackets over here, I have two things plugged in within the angle bracket. I have the regular T, so this we already know. But this time, so this may look something interesting, is it? Because generally speaking, previously we learned the keyword extends, is it? And the extends is used for what? It's used for inheritance, okay? But here, be careful, this doesn't mean inheritance, okay? So over here, this extends is used for what? Over here, what we discussed is called bounded generic type. Okay, so your generic representation is still going to be U. It's U, okay? But what can U cannot be like T. T can be any type. Any type means it can be string, is it? Can be a number, integer, can be character, can be like a Boolean, is it? So any type. So for this T just any type. So no restriction. Okay, any type, can be employee, can be account, can be any type. Okay, then how about U? Is it? And this time we call it a bounded. And why we say it's bounded? U has a limitation, okay, has a restriction. What its restriction is, it can only be any type from number or its subtype. Okay, number subtype is what? It can be integer, float, those stuff. Okay, and it cannot be, so it cannot be like a string or employee. So it cannot be those type. That's what this part means, okay? Because sometimes that's what this extend means. So this is, it limits its upper bound. Is it? And the upper bound can go up to number. It can be number or it's a subtype. So it cannot be allowed any other type. But why it's still called generic? Because it's still quite flexible. It gives you see, not just type number, is it, or just integer, is it? It still allow you within that superclass and all of its subclasses. So that's what this part means. So in this example, what we define here is we have two instance variables, one as T and one as U, and U is bounded. So then for this measurement instance, is it can only be allowed number, is it? Because any kind of measurement, you can measure like a nano level, is it? And you can go to like a space level, is it? So the measurement can be, but it's all numbers related. So that's why here we define it as cannot go beyond the numbers. And then we have the get type. So similar, you just return whatever the generic type you define. And we can have set, function, it's similar. And over here, we just call the toString that you can still provide override of the toString. So over here, we provide our override the toString method, and you just invoke whatever the toString they provide. And then next, let's take a look at the application part. Okay, this time when we want to use it, so we define our first example, our first instance variable y. This instance, this time what I plugged in? I plug in with a string, and I also plug in with a integer, and then you can set its type and its measurement, and we can call, we can output it. So here it's pretty straightforward, So not a lot of new thing over here. And then let's take a look. The second one, the second instance variable, you can see for the corresponding t part, this time we didn't use a string, we use a Boolean, and for the u part, I still plug in with integer, but it's, so integer is a subtype of number, and because it's subtype of number, so this is allowed. So that's allowed, okay. And the Boolean is still match, But you can see from string and the Boolean, they two have nothing to do with each other, So that's just a very generic T, And it allows any type. So that's the second instance. And then for the third instance, what we created is with a string type, and the second corresponding u1, this time it's a float, And the float is still a subtype of number, so it's still allowed. But after you go home, you can try. If you do something like this, if you plug in first one with integer and second one with string, your program won't be able to be compiled. It will say there is type error, okay? So over here, once again, this proves the Java program language, Java languages strongly typed programming language concept. So it's strongly typed, okay? Not like some other programming language like Python and the JavaScript, they are not typed programming language. But for Java and the C++, those, they are strongly typed programming language. So the advantage of strongly typed programming language, when the program compiles, they will do all of the type matching check, so it can avoid a lot of type assignment error. And then same thing, you can just assign some corresponding items to this instance variable. Okay, nothing new here. And what next? What next? Let's take a look over here. I define a method. So over here, I also define a generic method. And this time for my generic method, it's called isAscending. This is our generic. And its parameter is an array. And the array type is what? Is a very generic type, T, okay? But if you take another close look, this is a generic type, is it? And for this generic type T, this time it has some upper bound restriction, is it? What's the restriction is? They said extends what? Comparable. And the previous we learned is that comparable is what? It's an interface. It's not a class, is it? So what over here then it means the upper bounded means what? It means whenever you do plug in the concrete class, the concrete class must implement must implement what? Must implement the comparable interface. If your class didn't implement this comparable interface, then you cannot call this method. Okay, so that's what this definition means. And it's quite convenient, is it? Because a lot of time when you write some method, is that you want a certain class that has certain features be plugged in. It may not need to be like some subtype, is it? So this time doesn't necessarily mean that they all need to come from the same super grandparents, is it? It doesn't need that. They can come from different grandparents. But if all of the, if your class has implement the comparable interface, then you can go ahead to use it, is it? Because what over here we do is we want to check if the array is in ascending order, is it? So what we can do is you want to compare the specific element with whatever the next after it, is it? Next after it, generally you want to call the compare to method, is it? And the compare to method, who implement compare to method? The comparable interface, is it? That interface support this compare to method because this is much more generic with whatever you just do this kind of the greater than comparison operator, is it? So that's not going to be very applicable for this comparison operator, okay? So that's why over here, then we can make it more including, okay? So then let's take a look over here, is it? So this time, let's see, we have an integer array. So this array's type is integer, is it? And make sure it's not allowed the primitive type, okay? It got to be some concrete class type. So this is integer. And if you check the integer class official document, you can find the integer class implements that comparable interface. Okay. So it does implement, okay? So that's why over here you can plug it in, okay? And then for the second one, the second array, it's a string array, is it? And the string, it also implements the comparable interface. Is it? That's why you can also plug in, is it? But this time we can see integer and string, these two, unless both of them, of course, come from object, is it? But besides that, they don't share any other common features, is it? But this time, you can plug in with this is ascending method. It's because what? It's because both of this class implement this comparable interface, okay? So that's why this also works, okay? So over here, this second example, what it discussed is whenever you define your generic type, you can also define the bounded generic type. So bounded type, Okay, and with this bounded type, what over here we call the extents. Okay, we use that extent. That extent has nothing to do with the superclass. Okay, it doesn't mean superclass. It's not the definition of the superclass. So what over here is just to define the upper bound can be. And over here, the upper bound doesn't need to always be a class, okay? So it can be class. It can also be some interface, like what we show. Is it like a comparable interface? That's also allowed. So that's a key point for this second example. And we can run it to take, yeah, so you can see it does work. Is it? Okay, so this is the second example. And I don't think I'm going to have enough time to finish the third example. So we will leave the remaining generic example discussion to tomorrow's class. So do you have any questions? I don't want to share. I needed to I can type. So do you have any questions? And the generic is quite important part, because once we understand this part, and later on when we discuss collections, we can fully understand it. Okay, and also it's quite useful. And whenever you define some of your own class, if you want it to be more generous, then you can also make it as a generic class. So any questions? No question? I didn't see. If there is no question, then how about let's just stop here today. And I will see you all tomorrow. But let me try, because I needed to keep track of who is here today. I can give you some bonus points, okay, as what I said. Can every one of you just send something to the chat? I remember over the chat, I can save the chat so that I can keep track of the name here. Then I can add off the so would you please, if you are here today, you just send whatever, yeah, in the chat, so I can keep track of every one of you who are here today. Everybody already sent your chat? Okay, very nice. Do you all have any other questions? If there is no question, then I'm going to see you all tomorrow. Bye.
Bye.
Bye.